What if I told you that over 40 billion Oreos are made every year, yet no human hand is involved in shaping or assembling them? From the tallest stacks of cocoa powder to automated arms flawlessly layering that creamy center, the iconic treat you love is crafted with mind-blowing precision. Have you ever wondered how these machines manage to produce 3,000 cookies in just 1 minute? Let's step inside the factory and uncover the secrets behind this industrial marvel. What connects cocoa farms in West Africa to the Oreo in your pantry? It's a story driven by the scale and precision of a system that stretches across continents, blending raw ingredients with complex technology. Cocoa is at the heart of this journey. Sourced primarily from Ghana and Côte d'Ivoire, where rich, fertile soils produce some of the highest quality beans in the world. These beans begin as pods, carefully cultivated by local farmers, whose expertise ensures consistent flavor and texture. After harvest, the pods are fermented and dried under the sun, a crucial stage in developing the cocoa's signature taste. From here, the beans are shipped to processing facilities where they're cleaned, roasted, and pressed into cocoa mass, beginning their transformation into the chocolatey essence of an Oreo cookie. But cocoa isn't the only key ingredient behind Oreo's iconic flavor. Sugar, often sourced locally depending on the production facility's location, complements the cocoa's bitterness with sweetness. One lesser-known component is the canola oil, chosen for its neutral flavor and smooth texture, which binds the ingredients together. Vanilla extract, while subtle, plays a vital supporting role, enhancing the richness of the flavor profile without overpowering it. Each ingredient, whether major or minor, is carefully scrutinized before it's accepted into the factory. Maintaining consistency across millions of ingredients sourced around the globe is no easy feat. Nabisco, the brand behind Oreo, relies on a rigorous supplier approval process that includes strict testing for purity, freshness, and flavor. Suppliers regularly submit samples for chemical and sensory analysis, ensuring their products meet Oreo's high standards. For cocoa, this means examining everything from fat content to pH levels, while sugar is tested for grain size and moisture. Any deviation could result in a batch that doesn't meet the exacting standards Oreo users expect. So the testing happens continuously, both before the ingredients arrive at the factory and during the production process itself. Quality control doesn't stop there. Once cocoa beans are processed into cocoa powder, they undergo an alkalization process, also known as Dutching. This involves treating the cocoa with potassium carbonate, an alkaline compound, to reduce its acidity. The result is a smoother, richer chocolate flavor and the deep, dark color that sets Oreos apart. Without this step, the cookies wouldn't have their signature appearance or intense, slightly bitter taste. But this also adds another layer of complexity to the ingredient's journey. Transporting these ingredients across continents involves logistical challenges rarely seen on the surface. Cocoa powder may travel by sea freighter or rail, often requiring temperature-controlled containers to prevent spoilage during long trips. Sugar, which is far more stable, can be sourced from locations closer to each factory, reducing transportation times and environmental impact. Canola oil, sourced largely from Canada and parts of Europe, is shipped in massive vats, designed to maintain its purity until it reaches the production line. Every shipment must meet strict compliance standards, ensuring that what enters the factory is identical in quality and composition to what left the supplier. The global nature of Oreo's supply chain often raises the question, how do all these disparate ingredients come together to create the same taste, no matter where you buy them? The answer lies in the industrial blending process, in which raw materials from all over the world are brought into a single facility and combined at precise ratios. This ensures uniformity, even when individual ingredients may vary slightly from batch to batch due to natural differences. For cookies produced at a factory in the United States, for instance, sugar sourced locally in Florida will taste no different from sugar used in an Oreo made at a facility in Malaysia. The scale of these operations enables the production of billions of Oreos annually, but subtle adjustments during blending are what ensure the consistency you find with every bite. These adjustments might include tweaking the mix slightly, if one batch of cocoa powder is darker or less bitter than the previous one, or adjusting water content depending on the moisture levels in the sugar. It's all about balance, and it happens in a way most consumers never think about. What ties all this together is the precision involved at every level. By the time cocoa, sugar, and other ingredients are blended into the final mix, they've gone through several stages of scrutiny, transformation, and optimization. And this is only the beginning. Once the ingredients are loaded into massive industrial mixers, they're ready for the next phase of the journey, being shaped and baked into the base for the most popular sandwich cookie in the world. Transforming raw ingredients into the Oreo dough requires precision on an industrial scale, far beyond what you'd find in a home kitchen. It begins with enormous mixers, capable of handling hundreds of pounds of material at once. These machines blend everything, from the dry ingredients like flour, sugar, and cocoa powder, to liquids including canola oil and water, creating a smooth, uniform mixture. Bags of sugar weighing hundreds of pounds are emptied into the mixers alongside equally massive quantities of cocoa powder. Each batch is carefully measured and added in specific proportions to ensure an even mixture. Canola oil, an often overlooked ingredient, plays a key role here by binding the dry mixture into a dough that's neither too crumbly nor too sticky. What follows is a process that reflects scientific precision. After the dry ingredients are first blended in the mixer, the canola oil mixture is slowly poured in to begin forming dough. Next, water is added just the right way, helping to transform this dry blend into a thick, chocolatey batter. Inadequate mixing or incorrect ratios could throw off the entire consistency, so every step is closely monitored. Large mixing paddles rotate in carefully timed intervals to ensure even blending, and sensors built into the machinery monitor temperature to prevent overheating. This environment is a far cry from a traditional baking setup where inconsistencies are much more likely. Unexpectedly, the Oreo dough requires cooling, not just as part of its storage, but during its preparation. At this stage, dry ice is added to the dough during mixing. The dry ice chills the mixture quickly and effectively, ensuring it doesn't overheat from the friction generated by the massive industrial paddles. Overheating the dough could ruin its structure, causing it to lose the firmness necessary for proper shaping and baking later. The cooling process also helps maintain a consistent texture, making it easier to manage as it moves through the subsequent stages. This step highlights the kind of detail-oriented engineering that goes into creating what might seem like a simple cookie. No batch of Oreo dough is complete without its leavening agents. Baking soda and baking powder are carefully incorporated at a critical point in the process. Their role is to give the cookies their desired rise while baking. But timing is everything. If added too soon, the leavening agents could activate prematurely, compromising the final structure of the cookies. To avoid this, they are introduced toward the end of the mixing process, ensuring that their effects take hold only during baking. The leavening also helps create the crisp texture Oreo cookies are known for, giving them that satisfying crunch with just the right amount of density. The dough's iconic chocolate flavor owes its depth and color to the use of alkalized cocoa powder, an ingredient that plays a starring role by treating the cocoa powder with an alkalizing agent. The natural acidity of the cocoa is neutralized. This process, known as Dutching, results in a smoother flavor profile and the unmistakably dark appearance of the cookie. Alkalized cocoa not only enhances the taste, but also contributes to the cookie's uniformity in every batch. Without this step, the cookies wouldn't have the richness people expect from an Oreo. Once the dough is fully mixed, cooled, and ready, it's time to prepare it for shaping. From the massive industrial mixer, the dough is transferred to a molding system, where it's portioned into smaller, consistent pieces. These portions are then fed into a machine that shapes the dough into its distinct, round form. This is also where the iconic Oreo design is pressed into each cookie. The molding machine, engineered to precision, stamps the intricate pattern onto the surface of each cookie, creating the well-known appearance. This seemingly simple step is made possible only by tightly controlled technology. Any inconsistency in dough texture would disrupt the process entirely. The molding machine's speed is just as impressive as its precision. It can produce thousands of cookies per hour, meticulously shaping and stamping each one without errors. To maintain this efficiency, the dough must remain firm yet pliable, striking a balance that ensures clean, distinct patterns without cracking or breaking. This consistency and texture is a testament to the earlier steps, where the detailed work of mixing, temperature control, and ingredient timing all come together. The final step in this phase ensures the shaped dough is perfect for baking. Workers and machinery alike keep a close eye on the pieces as they move down the production line, ensuring every stamped cookie meets quality standards. By the time the dough enters the ovens, it's already recognizable as the base of the Oreo, precision engineered for the perfect bake. But what comes next, the baking itself, is where the science of timing and heat begins to transform these mere shapes into the signature cookies we know. The Oreo cookie isn't just a treat, it's the result of a process that spans continents, involving intricate machinery and cutting-edge precision. From cocoa farms in West Africa to automated assembly lines crafting 3,000 cookies per minute, every step reflects a balance of tradition and technology. Over 450 billion Oreos have been sold to date, a testament to the consistency and care that define their production. Next time you twist an Oreo apart, consider the global teamwork and innovation behind its perfect balance of crunch and cream. And this is only part of the story. Stay tuned to discover how the iconic filling comes to life.